Life feeling a bit ordinary? Travel choices a bit tame? Head beyond the asteroid belt for an out-of-this-world experience. Welcome to Jupiter, home of high adrenaline adventure. Plunge into its mysterious depths.
You drop through the clouds, it would get darker and darker, hotter and hotter. At the center, the temperatures are hotter than the surface of the sun, and the pressures are unimaginably high.
Stormy on the inside and stormy on the outside.
I like to watch hurricanes on TV. You know, the Great Red Spot being the biggest hurricane that we know of, and it having been there for 400 years, to see this would be pretty cool.
Want more bang for your buck? Thrill seekers should head to Io, Jupiter's exotic moon of fire and brimstone.
To see Io just blasting off these huge volcanic plumes covered in glowing volcanoes, it would be a pretty amazing place to see.
Escape Io's hot zone with a dive into the ice-covered alien ocean of neighboring Europa. Just the place for a close encounter of the weirdest kind.
Is there a reason to go to Europa? You bet. It's a totally unexplored world, and it probably has the highest probability of life off this planet.
Choose Jupiter, and a change of scenery is guaranteed. With its 62 alien moons to explore, out here, there is something for everyone. Tempted? There has never been a better time to take a giant leap to where no human has gone before. To follow in the footsteps of our robot pioneers and explore the planets of our solar system.
Oh man, that's incredible. My golly, this time goes fast.
A tour of the solar system wouldn't be complete without a visit to its largest planet.
Man, that is hard.
But with the grandest sights, biggest dangers, and greatest mysteries all on the itinerary, it pays to brush up before blast-off. Consider this your personal guide to exploring the kingdom of Jupiter. Enter the court of an alien giant.
Jupiter is one of the most spectacular places in the solar system. If you are approaching by spacecraft, you could see from a long distance the cloud patterns of Jupiter. It's incredibly complex, constantly changing multicolored clouds that are like nothing else in the solar system.
Jupiter takes its name from the Roman king of the gods. Fitting for the brooding and mysterious king of the planets. Calling it the biggest planet in the solar system doesn't do it justice. Jupiter is a world so roomy that it could swallow every planet and moon in the solar system and still have room for more.
If you move the Earth, you could put it inside the Great Red Spot, which is the largest storm there, and there are several other spots that are about Earth size. So everything on Jupiter is big.
You can fit 1,000 Earths inside Jupiter. It's huge, and yet it's quite underdense. It's made of almost entirely hydrogen and helium.
This giant gas bag is built from the flimsiest materials in the universe. But for all its squishy bulk, it's a great little mover. Jupiter spins at such breakneck speed that it bulges at the equator. So fast, in fact, that a day here lasts less than 10 hours. the shortest of all the planets. Our gaze was first drawn to the attractions of Jupiter 400 Earth years ago, when Italian astronomer Galileo pointed his telescope toward the planet on January 7, 1610. His curious novelty quickly became one of the most powerful scientific instruments of all time and turned our world on its head.
What he saw for the first time was that Jupiter had 4 moons, and he could see those 4 moons were going around the planet. And this is what really first told him that the Earth couldn't possibly be the center. Here were objects going around something other than the Earth.
It was a revelation. Io, Europa, Callisto, and Ganymede. Were these worlds like our own, circling a distant master? It's a cosmic experience anyone with a backyard telescope can have. Point at Jupiter and you'll see for yourself.
Jupiter is like a little miniature solar system by itself. It has many moons, 4 of which are very large and bright, the rest of which are very small and faint. But these moons are all different.
The court of the king of the planets is crowded. At last count, an entourage of 62 moons was in attendance, all dancing to Jupiter's heavy gravitational tune. It's even crowned by a trio of faint gossamer rings. Jupiter is a planet that knows how to exert its influence on the solar system and how to impress even the seasoned traveler. You can fly around the Earth in a jumbo jet in less than 2 days. Try this on Jumbo Jupiter, and you'll be in the air for 3 solid weeks, refueling about 50 times. Not only will you get sick of the food, there's nowhere to land.
You don't actually have a surface of Jupiter. You shine a big, strong radar pulse at Jupiter, and what you get back is 4 tiny blips. You see the moons of Jupiter just fine. In fact, we can study them by radar. Jupiter isn't there. It's like a stealth planet. If you had radar eyes, you'd wonder what these things were circling.
Boys, you know, man, all getting down into your work.
For a stealthy planet, Jupiter makes a big blip on the space travel radar, and it's a target worth the trip. The best way to test fly a trip to Jupiter is to retrace the extraordinary journey of the only spacecraft to orbit it.
We have ignition and liftoff of Atlantis, the Galileo spacecraft bound for Jupiter.
Launched by shuttle, the Galileo spacecraft left Earth in 1989 for an odyssey that lasted 14 years. The first 3 were spent simply trying to leave the neighborhood with enough speed to go the distance. 3 times farther than Mars, about 500 million miles, the road to Jupiter is a long one, with a few bumps along the way.
Asteroids! You are there as they brave the staggering showers.
Halfway there, you bump into the asteroid belt.
It's not like in the movies where you're dodging asteroids at every second. It's the space is very big and the asteroids are a long distance apart, so you could travel through it quite safely.
With 250 million miles still to go, you've already entered Jupiter's sphere of gravitational influence.
The presence of Jupiter probably stopped a large planet from forming in that region, and a lot of leftover junk from the origin of the solar system has persisted to the present day.
The next thing you run into you can't avoid: the leading edge of Jupiter's magnetosphere. It's invisible, but the sound is like a signpost.
It's like you hit something. So you're do-do-do-do-do, and then bam! And so, now we're in the Jupiter system.
Want to explore further? Be warned. You have just crossed the threshold into the most hazardous piece of space real estate in the solar system.
At Jupiter's magnetosphere, there's almost nothing that can protect you. That's a kind of a don't enter this zone at any costs. And if you do, you better be prepared to pay in terms of your electronics. You are toast.
Step inside Jupiter's raging magnetic field, and you enter a radiation hot zone of staggering intensity, where incoming charged particles from the sun are whipped into a relativistic frenzy. Buffeted by the solar wind, the magnetic maelstrom streams back almost as far as the orbit of Saturn.
The magnetosphere of Jupiter, the largest thing in the solar system, if it were visible from the Earth, it would be the size of the full moon in the sky.
This was like a magnet to NASA, setting off for deep space for the first time in the early 1970s.
The Pioneer missions were initially designed to fly the first few test instruments into the environment, sample how bad the radiation was, and oh, by the way, let's kind of throw a camera on there. Maybe we can get 2 or 3 pictures along the way. It's almost like putting your toe in the water.
The water proved deep and deadly. But despite faltering instruments and fuzzy photos, the Pioneer flybys paved the way for the missions that followed.
What Pioneer told us was that Jupiter's radiation belts were even more intense than we had anticipated. And that meant that our next mission, Voyager, suddenly went into rework real fast to put more shielding on board. Shields up, Captain, because we knew we were going to be getting a lot of radiation dose.
When the space-hardened Voyagers 1 and 2 flew past in 1979, on their way to the outer solar system, Jupiter's great mysteries only deepened. How were these powerful magnetic storms generated inside a giant ball of gas? Why was one moon boiling with volcanoes, while its neighbor remained covered with ice? And what lies beneath Jupiter's clouds? It was Galileo's mission to investigate. Approaching Jupiter in 1995, 6 years after launch, Galileo began to send postcards that widened our eyes to the wonders of the Jovian system.
As you get closer, you start to see the 4 big moons of Jupiter, Io, Europa, Ganymede, and Callisto, which immediately are apparently very different from each other. Io is quite strongly yellow in color. Callisto is very dark. Europa is very bright. They have markings on them that are very distinctive, so you never mistake one of them for another.
And there's no mistaking the star of the show. The cloudy face of Jupiter is the most colorful and hypnotic in the solar system.
Engines beginning throttling down now.
Packing for a giant ball of weather? It's quite a mix. Cold and dry, hot and steamy, poisonous and pressurized. It's best to dress for everything.
Roger.
I'm a weatherman. I like weather at all altitudes, from hurricanes near the ground to the weather of the top of the atmosphere.
Jupiter is a weatherman's dream. Furious jet streams blow alternating bands of clouds in opposite directions at speeds of over 300 miles per hour. Lightning that's 10 times more powerful than on Earth. Hailstones that could be the size of footballs. It's wild out here, but surprisingly predictable.
We can make a weather forecast for Jupiter more successfully than we can make one for the Earth. If you want to take close-up images of the Great Red Spot, you'll have to know where the red spot's going to be 2 or 3 weeks in advance. And now you could never do that with a storm on Earth, but it was not difficult on Jupiter because the red spot is so well behaved. It just chugs along.
Jupiter's famous red beauty spot had been a puzzle ever since it was discovered in 1664. This seemingly perpetual storm is more like a giant eddy, caught between rivers of cloud, than a hurricane.
If you were floating in a balloon, the center of the red spot might be rather calm, but you'd be going fast. Your balloon would be going faster than hurricane winds, but it might be a smooth ride.
This storm is a sight to behold, towering 5 miles into the sky. But why the color?
One of the most embarrassing questions that any school child can ask an astronomer is why is the red spot red? Things like sulfur compounds like phosphorus in small quantities can do that. But if the truth be told, understanding the colors of Jupiter, which were one of the first things noted by astronomers a couple of 100 years ago, still eludes us in terms of a detailed explanation.
The other unsolved puzzle, since the Voyagers beamed back the first weather reports, is why there is a red spot at all.
We sort of expected, as we got close, things would be rather quiet, because how could a storm last for 300 years? But in fact, it was more turbulent, and that raised a mystery. How can a storm last for so long?
Hamid Calais grapples with this part of the problem in a very down-to-earth way, blowing miniature Jupiter bubbles in his lab in Bordeaux.
The big mystery is its persistence. It's rotating at a certain rate, and this movement is over thousands and thousands of kilometers. I mean, the red spot is huge. You can put 2 to 3 Earths in it. So everything is telling us that things like this should be just annihilated by the turbulent flow around them.
By heating a half-soap bubble through contact with a metal surface, he mimics how the thin fluid atmosphere of Jupiter might respond to heat rising from deep inside the gas ball planet. Sure enough, swirling storm patterns emerge spontaneously.
The interest of the soap bubble, or at least this one, is that we get single vortices that generate. We don't do anything to generate them, and they just nucleate out of the blue, basically, out of the turbulent motion around them.
Space agencies spend billions of dollars to send spacecraft to look at these things. Hamid Calais's approach lets you explore Jupiter without leaving your bathtub. There's only so much, though, you can resolve from a safe distance. To get to know the planet's heart and soul, you'll need to take the plunge. Picture a suicide dive into the mysterious depths? Relax. Galileo's already done it for you.
We separated the probe from the Galileo mothership. We were flying in toward Jupiter, basically a ballistic bullet.
The Galileo probe went in at an unbelievable speed because Jupiter's gravity just accelerated it on the way in.
Now, you've seen pictures of meteor fireballs in the Earth's atmosphere. Well, this is hundreds of times worse in terms of the heat and shock. It was more like sitting in front of a nuclear blast.
The violence lasted only minutes. On December 7th, 1995, the probe dropped through alien skies at about 60 miles an hour and with all instruments blazing.
In terms of what it might look like, it's not dissimilar to the upper atmosphere of the Earth. If you were descending along with the Galileo probe and looking out the window, you would see some thin cirrus clouds go by, then you might see some other clouds that might be somewhat strange.
but it would be like dropping into an alien chemical factory. These clouds not only look strange, they really stink.
You have more than one substance forming clouds on Jupiter. Ammonia, which is cleaning fluid, then H2S, which is the rotten egg gas, and then below that is water.
Like giant thunderheads, these deep water clouds are the source for Jupiter's ferocious lightning. Things are getting hotter now, and the pressure's heavier. Then the clouds end.
If you imagine going through the cloud decks of Jupiter and emerging from underneath the base of the water clouds, it would be like breaking out into clear skies and descent on an airliner on the Earth.
This could be the most terrifying sight in the solar system. Clear skies above a bottomless pit, an infernal drop into the depths of Jupiter's endless sky.
You may have raindrops evaporating into the hot interior of Jupiter, but there's no ocean down there. There's nothing but just more hot atmosphere.
Transmission was lost about 100 miles below the cloud tops.
Just hours after we lost contact with the probe, it descended into part of the atmosphere where the probe material itself would have started evaporating. So in sort of a Zen closure, our atmospheric probe became part of the atmosphere it was studying.
Heroic as the descent was, the probe penetrated only the outermost onion skin of Jupiter. Peel back the layers that Galileo couldn't reach, and the mysteries deepen. We must now travel to the very strange heart of Jupiter to answer a true cosmic puzzle. How a gas giant is born. There is no boundary to run into, no concrete surface. But far below the clouds, the pressure squeezes hydrogen from a hot gas atmosphere into a hot liquid ocean. It's deep. Keep going down another 12,000 miles, and the liquid transforms again into something even stranger.
Temperatures and pressures would get to the point where protons lose track of electrons and nuclei lose track of their electrons, and you basically just have a kind of an ionic soup, which is very hard to imagine. It's just like trying to imagine yourself being inside a star, basically. Hydrogen, for instance, goes into what we call a metallic state. It is the electrically conducting fluid that's causing Jupiter's immensely powerful magnetic field.
This vast, secret ocean of seething metallic hydrogen, not a molten iron core, is the powerhouse generating Jupiter's dangerous energy shroud. But there is one more mystery hidden inside this giant alien onion. The key to the origin of the planets themselves. 400 years after Galileo first trained his telescope on Jupiter, Scott Bolton is following in his footsteps. Scott is tour director for the next spacecraft to pay the planet a visit. The Juno mission, launching in 2011.
Juno's taking the next step beyond what Galileo first showed us, which is the telescope to look at the outside, and we've come up with ways of looking at what's inside of Jupiter. And from this, we'll understand how it was built and how it came to be.
From what we understand, the planets formed from the disk of gas and dust swirling around our newborn sun. Matter collided with matter. It was a game of gravitational survival of the fattest. A race that Jupiter ultimately won. Planets, like people, are what they eat. Did Jupiter gobble up most of the abundant lightweight gases first, before all the solid stuff started banging around? Or did it form like all the other planets, but grab more than its fair share of ice and gas from the cosmic chiller. The molecules of Jupiter's first meals, rocks, ice, vapors, or dust, are still trapped somewhere inside. When the Galileo probe measured higher levels of rare and heavy gases than anyone was expecting, things got more complicated.
That did not fit any theory of how the planets were made. And so in one quick swoop of time, all the theories of how the planets were made, including the Earth, went out the window.
Juno will continue where Galileo left off, trying to unravel the mystery of Jupiter's formation.
We do this by looking down deep in Jupiter and understanding first whether there's a solid core in the middle of it.
If gravity measurements show no solid core, then Jupiter formed early, like the Sun. With a core, then its birth came later, once solid materials were created. By measuring water content, Juno should also reveal how hot the solar system was when Jupiter formed, and where. Some theories suggest the planet muscled its way in to be closer to the Sun. With gas giants like Jupiter being discovered now all over the galaxy, resolving the puzzle of its origin is taking on a whole new significance.
Go ahead, throttle up, Capcom.
Arriving at Jupiter and looking for somewhere to land, a moon with a view, perhaps. Choose carefully from the 62 solid surfaces on hand. Some destinations out here are red hot.
Status booster, go.
While the atmosphere probe was disappearing into clouds in 1995, Galileo itself skimmed past Moon Io, put on the brakes, and slipped into orbit around Jupiter. Even at this stage, the team knew that Io, about the same size as our own moon, would be one of their prime attractions. This strange, pizza-colored moon orbits the closest of Jupiter's big 4 moons, and it's volcano central.
Well, this is one of those cases where the headline for the daily tabloid is actually correct. It's the most volcanic place in the solar system. There isn't any place on the surface where you're not going to find a volcano within 100 miles or so, usually less. And there's enough material coming out of those volcanoes to cover the surface over to a depth of a centimeter every year.
Fresh-faced Io has a makeover between every visit. No other world masks its age so well.
We were lucky enough to point at a volcano that happened to be having a major eruption at the time. We saw this line of fire fountains, actually so bright that they overexposed the camera, and produced a very dramatic evidence of just how active Io is.
Take a night flight, like Galileo's, over the surface of Io, and the view down to the churning lava lakes would be unforgettable. Imagine then, a visit to the surface.
If I were to lead an expedition to Io, where would I take people? I would go up to the hot lava, and I would climb mountains, and I would look at Jupiter on the horizon, and it would be a lot of fun.
The landscape might look quite a bit like a red and yellow sulfur-painted version of what you would see if you went to the big island of Hawaii, with the interesting additions of the fact that you have a very low gravity field and these geyser-like eruptions of sulfur dioxide gas, which give you a kind of a spray of condensing sulfur dioxide crystals rising up in 100-kilometer high umbrella-shaped plumes and falling back down to the surface.
Giant plumes, a snowfall of sulfur, fire fountains of lava, some even hotter than lava on Earth. Just why is Io cooking inside?
The reason for Io's tremendous volcanic activity is energy that's being pumped into it from the tides, raised by Jupiter. I'm not talking about liquid tides like out here in the ocean. I'm talking about the whole body of Io is being squeezed by tidal forces. So every day, the surface of Io at the equator, when it's closest to Jupiter, will be maybe 100 meters higher than it is when it's furthest from Jupiter. That's an awful lot of squeezing and pushing.
Io is like warm putty in Jupiter's gravitational hand.
Go. Guidance.
It used to be thought that the chance of meeting alien life on the planets beyond Mars dropped close to absolute zero, much like the temperature. But that was before we knew where to look.
Go at 5:30, Capcom.
When life on Jupiter was first seriously discussed in the 70s, there was only one place worth considering: the clouds. Perhaps a whole community of aliens could live, drifting above in a Goldilocks zone where it's warm, wet, and sunny, much like plankton floating in the sunlit oceans of Earth. Always a long shot, the probe killed this idea when it found no evidence of complex organic molecules in the atmosphere. But when Galileo took a closer look at Europa, the picture changed.
Europa is a fascinating object. If you imagine descending onto a world that looks every place like the frozen wastes of the Arctic or the Antarctic, you get a pretty good impression of what's going on. It's very, very bright because the ice is very reflective and broken up in places where it looks like you have basically ice rafts on the surface. It would be like flying over a moon-sized ice field, basically. And landing on the surface, you would not see any large mountains. You would see crisscrossing ridges that would look like killer ski slopes every place.
Killer ski slopes with pale pink stripes, and all with the icy surface at a very cool 260 degrees Fahrenheit below zero.
So if the ice is so cold, is it like just really, really hard? Like
yeah. It acts just like rock. So it's as hard as rock at the surface of Europa.
No doubt, the first person to return from the ski slopes of Europa will have some pretty tall stories to tell. Europa specialist NASA's Bob Pappalardo would like to be one of them.
Oh, I'd love to get down to the surface of Europa. To walk around that surface, it would probably kind of crunch under your boot. It's a very bizarre place and really stretches our minds to think about what's possible in an ice world that's orbiting a giant planet like Jupiter.
Europa itself is stretched by the gravitational strain of being locked in an orbit with Io and Ganymede around its giant host.
Every Europan day, as it orbits Jupiter, the stresses rotate around. And if a crack forms moving at just the right speed across Europa's surface, about the speed a person can walk, it would follow a curved path and explain the pattern that we see on the surface. You'd be able to hear the cracking, probably, of Europa's ice shell. You couldn't hear that if your head were in space, but as soon as you put your head to the ice, you'd probably hear Europa creaking like a boat.
The processes that heat Io are operating on Europa as well, but on a less dramatic scale. And so there's constant changes in Jupiter's gravitational pull that are distorting the surface, and that's generating heat in the interior.
This is a clue to Europa's biggest secret. Its frozen, icy shell floats above a vast hidden ocean of salty water, warmed by Jupiter's intense tidal embrace. The ocean of Europa is thought to be over 60 miles deep, deeper than any on Earth. If so, there is more water hidden on Europa than on our own blue planet. And with water comes the possibility of life.
This sounds like a place where life might exist. It's protected from the radiation environment underneath all of the ice, and it's sort of the same sort of temperatures and pressures as we have in Earth's oceans. I have friends in the oceanographic community that want to get wet right now. It says, drill me a hole, I can get a robotic submersible down there.
If there is life down here, the challenge is getting to it.
What we don't know is how thin or thick that ice covering is. We refer to this as the pizza problem sometimes. You like thick crust or thin crust. And estimates range from that crust maybe only being a few kilometers thick in places to being as thick as maybe 10, 20, 30 kilometers.
There are folks who are starting to think about what it really takes to melt into Europa's ocean. What kind of autonomous vehicle could make its way through ice and then swim around that ocean, find interesting things, and report that back to the surface, and then beam it back to Earth.
Bill Stone has gone where no man has gone before. A pioneering cave diver and aerospace engineer, he now wants to go diving in an alien ocean some 500 million miles from home. And he's developing the technology to do it.
We started off with the idea of two things. One is this gadget that swims has to be intelligent enough to understand where it is. What we wanted to create was a field microbiologist on silicon that did everything that a good microbiologist would go out and do in the field.
His Depth X and Endurance Intelligent Autonomous robots have already proven themselves as very capable explorers in impossible underwater situations. Mapping deep subterranean caverns in Mexico, and now exploring deep below ice-covered lakes in Antarctica. As these robot submarines accomplish great missions, the possibility of one day melting our way into Europa's deep ocean is moving from fiction toward fact.
Let's just imagine that we're on a little spacecraft with the capability to melt through the ice. We push down, boom, plowing through the ice. We hit the water. That may be an interesting zone, right there at the interface between the water and the ice. When we look around, what we might see is a community of organisms that are growing on energy that's coming through the ice, oxidants, maybe even oxygen, produced by sunlight on the surface of the ice being mixed through the ice, reacting with the water, and at that interface, energy is being released. Organisms are consuming that energy. Okay, that's cool. We can go deeper down to the bottom of the ocean. There we see maybe hot hydrothermal vents, deep sea vents like we see on Earth, where tidal energy, which is being caused by Jupiter's gravitational pull, is pumping hot fluids through the crust. That's what we'd be hoping to find.
On Earth, we have found communities of life doing just fine, cut off from life above, and huddling for warmth and sustenance around volcanic vents in the deep sea. This is what makes Europa so appealing. There should be warm, salty water interacting directly with a hot, rocky seafloor.
Life is like a little battery. It runs off a chemical reaction. If that rocky mantle is hot, then, like black smokers on the ocean floors of the Earth, there could be the chemistry that powers life just pouring into that ocean from hot locations on that ocean floor. Really what we're talking about is probably not dolphins or whales or the Loch Ness Monster down there, but instead tiny microbes. But that's not to say that isn't extremely important. If Europa is an environment where we think there should be life, then it's important to know, is there? Does life get going easily given the right conditions? Or, for that matter, if there's no life in Europa's ocean and the conditions are favorable to life, why not? And how rare then is life as we know it on Earth?
T-minus 60.
We're approaching Mach 1.
Every time we send a spacecraft to answer questions, we end up asking more. Clearly, a return to Jupiter is in the stars.
There we go.
In 2003, with fuel and power running low, Galileo's 14-year odyssey was brought to an end. Deliberately, to ensure Europa remained uncontaminated by an out-of-control spacecraft with a load of earthly bacteria.
I was responsible for Galileo's bitter end on purpose. My friends always remind me to say, make sure you tell people it was on purpose. So the idea was to, come into the atmosphere of Jupiter with enough velocity that it would break up and be destroyed, pretty much right away. It's now part of Jupiter.
Meanwhile, back on Earth, our return to Jupiter is being planned. In the construction bays at Lockheed Martin, the Juno spacecraft is taking shape, getting ready for its close encounter later in the decade. And looking ahead, NASA and the European Space Agency are joining forces to send 2 spacecraft, one each, to orbit Ganymede and Europa.
So we launched in 2020 and we arrive in 2026.
This essential, detailed reconnaissance will set the stage for the ultimate goal of exploring an alien ocean by robot submarine.
Europa is a good place for robots. Why? Number one, it's a heck of a long ways away. Our propulsion systems are not ready for it to deliver people there. And second, the radiation environment on the surface of that moon is dangerous as hell. 5 minutes exposure to an unshielded human and you've received a lethal REM dose. So you don't want to put people on Europa, but we can definitely put robots there. And is there a reason to go? You bet, right? It's a totally unexplored world, and it probably has the highest probability of life off this planet.
One day, we might develop the magnetic field technology necessary to keep a human alive within Jupiter's radiation environment. But in the near future, our exploration will continue by machine.
The robotic program isn't about robots. It's a profoundly human activity that we're just sending pieces of ourselves out there to do these jobs.
Pretty soon you are using the eyes of the spacecraft as your eyes, and you get very attached to your heroic spacecraft, which survives numerous death-defying experiences.
If you listen to people who have been involved in these explorations over the years, they say, oh, that was the year we went by Enceladus, or that's the year we went to Neptune. It's very, very much a personal thing. The difference between here starts blurring.
To be so familiar with such alien worlds shows how far we've traveled thanks to Galileo, both the man and the robot. And the voyage continues.
I'd love to visit Io if I could. It's one of my favorite places in the solar system. You would always have Jupiter hanging in the background, huge and multicolored and constantly changing. It would be a pretty amazing place to see.
For a trip to study the weather of Jupiter, I'd get down in the atmosphere where the lightning is being formed, and I'd just look out the window and enjoy the flashes.
Europa kind of has it all. I'd love to be able to poke around down there in Europa's ocean. Might there really be life down there? It's probably not something I'll know in my lifetime, but we'll set the stage for the next generation of explorers to find out.
However we reach across the ocean of space, the kingdom of Jupiter has a lot to offer a visitor from Earth. It's far out and far away, and tempting us to visit.